Welcome friends. In this tutorial we will learn about graphs. What is a graph? A graph G equal to V comma E is composed of V set of vertices, E set of edges connecting the vertices in V, and edge E equal to U comma V is a pair of vertices. Example, consider this graph. It has vertices A, B, C, D and E. It has the edges AB, AC, AD, BE, CD, CE and DE. Now let us see some graph terminologies. If V0, V1 is an edge in an undirected graph, V0 and V1 are adjacent. The edge V0, V1 is incident on vertices V0 and V1. If angular brackets V0, V1 is an edge in a directed graph, V0 is adjacent to V1 and V1 is adjacent from V0. The edge V0, V1 is incident on V0 and V1. Degree of a vertex. The degree of a vertex is the number of edges incident to that vertex. For directed graph, the in degree of a vertex V is the number of edges that have V as the head. The out degree of a vertex V is the number of edges that have V as the tail. Consider these examples. The first graph, which is an undirected graph, all nodes have the same degree, that is 3. Consider the second graph. It is a tree and the root node has the degree 2 and the two child nodes has degree 3 and the rest of the nodes have degree 1. The third graph G3, it is an directed graph. The in degree of 0 is 1, the in degree of 1 is 1, the in degree of 2 is 1, the out degree of 0 is 1, the out degree of 1 is 2 and the out degree of 2 is 0. Path. Path is a sequence of vertices V1, V2 up to Vk such that consecutive vertices Vi and Vi plus 1 are adjacent. Here, consider this diagram. Here ABEDC is a path, and the second diagram, here BEDC is a path. Simple path. There are no repeated vertices as shown in the figure. A cycle. Cycle is a simple path except that the last vertex is the same as the first vertex. As shown in the diagram, ACDA forms a cycle. Connected graph. Any two vertices are connected by some path. Subgraph. Subset of vertices and edges forming a graph is known as subgraph. Connected component. The maximum connected subgraph is known as connected component. Example, the graph below has 3 connected components. Now let us see subgraph examples. Here the possible subgraphs of graph G1 and G3 are shown. Tree. A connected graph without cycles is known as tree. Forest is a collection of trees. A complete graph. Complete graph is a graph in which all pairs of vertices are adjacent. Oriented or directed graph. A graph where edges are directed is known as oriented graph. Directed versus undirected graph. An undirected graph is one in which the pair of vertices in an edge is unordered, that is V0, V1 equal to V1, V0. A directed graph is one in which each edge is a directed pair of vertices V0, V1 not equal to V1, V0. It has a tail and a head. Now let us talk about graph representation. The graphs are represented by using adjacency matrix and adjacency list. Adjacency matrix. Let G equal to VE be a graph with n vertices. The adjacency matrix of G is a two-dimensional n by n array, say at adj underscore mat. If the edge Vi, Vj is in E of G, the adjacent mat ij is equal to 1. If there is no such edge in EG, adjacent mat ij equal to 0. The adjacency matrix for an undirected graph is symmetric. The adjacency matrix for a digraph need not be symmetric. Examples for adjacency matrix. The matrix for the graph G1, G2 and G4 are as shown below. Graph G1 and G4 are symmetric. This is a logical representation of adjacency list. As shown in the diagram, consider the first diagram, that is a undirected graph. 0 is connected to 1, 2 and 3. 1 is connected to 0, 2 and 3. 2 is connected to 0, 1 and 3. And 3 is connected to 0, 1 and 2. Similarly, we can consider the other diagrams. Hence we have seen the basics of graphs, and in the next tutorial we will talk about the algorithms of graphs and its applications. Thank you for watching the tutorial.